Good day, grade 11 Senior High School of Cauayan City National High School. For today's video lesson, we will talk about t-distribution. In our previous lesson, we learned about z-distribution. It is used when the population variance is unknown and the sample size is large. That is, n is greater than or equal to 30. This time, you will encounter a new distribution called t-distribution. It is used in estimating the population parameter when the sample size is small or less than 30 and the population variance is unknown. Like the z-distribution or normal distribution, the t-distribution is a bell shape and symmetric about the y-axis, centered at 0, and the total area under the normal curve is 1. The t-distribution was also called Student's t-distribution. William C. Gosset formulated the t-distribution in 1908. He is an Irish brewing employee who was involved in researching new methods of manufacturing ale, type of beer. He published his finding using the pseudonym Student because brewing employees were not able to publish findings. Hence, the t-distribution is sometimes called the Student's t-distribution. Formula in finding the t-value of the t-distribution. We have the t, that is the t-value, is equal to x bar, that is the sample mean, minus mu, that is the population mean, divided by s, that is the sample standard deviation, having a formula of s is equal to the square root of the summation of your x minus x bar square divided by n minus 1, and divided by, back to the formula, that is s divided by square root of n, wherein your n is the number of your sample. Let's have the degree of freedom, wherein the formula is df, which is your degree of freedom, minus n, which is your sample size, minus 1. The left side is the degrees of freedom, while the top segment relates to the right tail probabilities, that is your alpha. I'm talking to the table shown in the slide. The entries within the table are the t-values or the critical values of t. There are no negative values since t-distribution is symmetrical. The region below of negative t-score is equal to the area above a positive t-score. The larger the degrees of freedom, the more it will approximately a normal distribution. Thus, the t-scores can be negative, but areas and probabilities cannot. Let's have an example. What is the t-value round to the nearest thousand when your degree of freedom is equal to 21 and your alpha is equal to 0.01? Referring to the table, degree of freedom that is equal to 21 and alpha that is equal to 0.01, that's located in the table. Degree of freedom that is 21 minus 1, that makes it 20, and then your alpha that is 0.01. Okay, let's combine it. We now have a t-value that is 2.51765. The t-value is the intersection between the left side column, that is the degree of freedom, and the right tail probabilities, that is your alpha, which is 2.51765. Another example. What is the t-value round to the nearest thousand when n is equal to 16 and alpha is equal to 0.05? So let's compute first what is our degree of freedom. That is df is equal to n minus 1, that is 16 minus 1, that is equal to 15. So we have a degree of freedom of 15. And your alpha, that is 0.05. Let's combine the two. Okay, so we have 1.753050. That is our t value when n is equal to 16 and your alpha is equal to 0.05. Let's have an example. Find the t-score which we can expect 99% of the sample means will fall if the sample of size 20 are taken on a normally distributed population. The cumulative probability is 1 minus alpha, that is equal to 0.99. Let's compute for the alpha, that is negative alpha, that is 0.99 minus 1. We will now have negative alpha, that is equal to negative 0.01. Then your alpha now is equal to 0.01. Likewise with the degree of freedom, we will now have the f is equal to n minus 1. That is 20 minus 1, that is equal to 90. To find the required t-score, move down the first column of the t-table until you get 19, which is the degree of freedom. Move across the row containing this entry until you get the column with heading of alpha, that is equal to 0.01. The value that we get is 2.53948. This shows that 99% of the sample means are expected to have a t-scores less than or equal to 2.539. We can say that 1% of the sample means will have t-scores less than or equal to negative 2.539. Let's have another example. Using the t-distribution table, find the degree of freedom and the critical values n is equal to 25 at 95% confidence coefficient. Since the confidence coefficient is equal to 95%, we have an alpha that is 0.05 and the degree of freedom that is n minus 1, that is 25 minus 1, that is equal to 24. The intersection between your alpha and your degree of freedom, that is 1.71 0882, which is your critical value. Find the t-value when your population mean, that is mu, that is equal to 43, and your sample mean, that is your x bar, that is 45, your standard deviation, that is equal to 3, and your sample size n is equal to 16. For the formula, we have t is equal to x bar minus mu divided by s divided by the square root of n. Substituting the given, we will now have 45 minus 43 divided by 3 divided by the square root of 16. Simplifying the numerator part, we have 45 minus 43, that is 2. Simplifying the denominator part of our denominator, square root of 16, that is equal to 4. Now, we will have our equation, that is t is equal to 2 divided by 3/4. Simplifying it, we will now have t value that is equal to 2.667. For clarifications and questions, don't hesitate to message me in my messenger account, that is Kim Francis Seasonal lang. Thanks for watching. Till next video lesson. Bye!